Right, let's have a look at polymers. What are polymers? Polymers are macromolecules, in other words, large molecules, made up of many simple repeating units, which we call monomers. And we're going to look at two types of polymers, addition polymers and condensation polymers. The properties of the polymer depend on the bond type between the monomers, the chemical nature of the monomers, and the presence of bonding between the polymer chains. Firstly, addition polymerization. This is where the monomers contain one or more double bonds, and these double bonds in the monomers are broken to join the monomers together. The polymer chain only involves the original carbon atoms that were involved in the double bond, and we'll come back to that sentence and explain it more in a moment. So here's an example of polypropene. So this is the monomer shown on the left. So the monomer is propene. It's 1, 2, 3 carbon atoms, and it's propene because of the double bond. And what happens is this double bond breaks and a new bond forms between neighboring monomers. So we end up with a long chain that looks like this, repeated again and again and again. Now, firstly, the way that we show a polymer is by showing the repeating part of the polymer drawn in square brackets with an N. In other words, just meaning a lot of these are next to each other to form the long chain of the polymer. Now, what we see back here is that the polymer chain only involves the original carbon atoms that were involved in the double bond. So you can see that here that it's only this carbon and this carbon which are involved in the double bond, and only those two carbons are part of the chain. This carbon down here comes from this carbon here. It's not part of the polymer chain. It's like a side chain on the polymer, but it's not part of the main polymer chain of carbon atoms. Those carbon atoms come exclusively from the carbon atoms in the monomer on either side of the double bond. Okay, condensation polymerization involves the elimination of a small molecule such as water or HCl, and this elimination of a small molecule takes place as the monomers join together. So firstly, let's look at polyesters. The first way, or one way of forming a polyester, is by having a monomer which has both a carboxylic acid functional group and an alcohol functional group. So for example, this monomer here, it has a carboxylic acid group on one end and an alcohol group on the other end. And if we take two of these and combine them together, what happens is we split the molecule here. So the carboxylic acid molecule splits here, and we split the alcohol group here, and we take out this H2O, and this O bonds to this carbon here. This O here is carbonyl oxygen, so it has a double bond to this carbon. So we take out this O, this H, and this H, and bond this O to this carbon. And we see that here, right? So this COO, so this O has bonded onto this carbon. And we have the rest of the molecule here on the right. Now, if we take a whole bunch of these and join them together, the repeating unit is going to look like this. Because if you can imagine, if we had more of these molecules on the left, we would take out this H. So the H gets taken out, and we would take out this O and this H. So these would get taken out as well. So the repeating part is going to start with the O, and then it's going to be ORCO. That's what we see down here, and then we see it again, ORCO. So it's this ORCO that is repeating again and again in the polymer. Okay, the other way of forming a polyester is by having two different monomers, one that is a diol, in other words like a double alcohol, and one that is a dicarboxylic acid or a diacyl chloride. So let's have a look here. Let's have a look at ethane 1,2-diol. So it's like ethanol, but it's got a hydroxyl group at both ends of the molecule. And a monomer 2, which is a rather complicated molecule, but the main thing to note is that it has a carboxyl group at both ends of the molecule, and it has a benzene ring in the middle. So what's going to happen here is we're going to split the molecule here split the molecules here and take out water, and this O is going to bond to this carbon. We see that bond here, so that becomes what we call the ester bond of the polymer. And so this is just showing two molecules joined together. If we join a whole lot of them together, then we would lose, again, we split the molecule here, so we lose this H, and we split the molecule here, we lose this O and H. So the molecule starts with O, which we see down here. Then we've got our C2H4, which is 2 lots of CH2, then O, and then C, double bond to an oxygen, benzene ring, and our other C with the double bond to an oxygen. And then we're losing this OH and this H, so they're not shown in the repeating unit down here. Okay, so that was polyesters. We can also have polypeptides or polyamides, where we have an amide link or a peptide link. So we talked about that when we talked about amides. So the amide link is CONH, and that's what forms our amide link. So we can take a diamine, so a molecule that has an amino group at both ends, and a dicarboxylic acid that has a carboxyl group at both ends, and we're going to remove water, so we're going to remove OH from the carboxyl group and one of the hydrogens from the amino group, and we're going to form a bond between the nitrogen and that carbon, and that's the bond there that's forming. So that's our amide bond or peptide bond or amide link or peptide link. Okay, so if we take if we want to make nylon, for example, we take a diamine, which is we've shown up here, has a string of 6 carbons in the middle and 2 amino groups on one on each end, and a carboxyl, a double carboxylic acid or a dicarboxylic acid that has a carboxyl group on both ends. And again, we're taking out the water molecule here between them. We're forming the bond between the nitrogen and the carbon. So that's our peptide link or amide link there. And if we were to have a lot of these bonded together in a long chain, then we would take out this H and this OH. So the repeating unit would start with the N, which is what we see down here, and would end with the C, which is what we see down here. And that would repeat again and again, and that is nylon. Okay, proteins. Amino acids can form peptide links because they have an amino group on one end and a carboxylic acid group on the other end. So we can form the amide link between amino acids. So this is an example of, well, if you have two different amino acids, so one, like two different alkyl groups, a different alkyl group here than we have here, then we're taking out the one of the hydrogens from this NH2 and the OH here. So, and we're getting our this carbon bonding to that hydrogen. So we get our peptide link that forms over there. And if we're just bonding two of them together, then this is what it would look like here. So we've removed H2O, so hydrogen from here and an OH from the carboxylic acid group. And we've taken out H2O and we've formed our amide link between the nitrogen and the carbon. So it's the ONH link there, the peptide link or amide link. And the rest of the molecule is shown on the left and on the right. And then if we were to make a long chain of those, which is what we're showing down here, we would take out one hydrogen from here and an OH from this end, and that would be our repeating unit. So that's what we see here. We start with our NH, and then we end with our CO over here on the right, and that would repeat again and again. And that is an example of a protein. So that's proteins forming from amino acids joining together. If we have two amino acids joined together, we call it a dipeptide. If we have many amino acids joined together, that's called a polypeptide. And when that polypeptide has a specific function, we call it a protein. And proteins are made up from a combination of about 20 different amino acids. Some common examples of proteins are insulin, collagen, and enzymes, which are biological catalysts. Okay, so that is your information on polymers.